factor of this. This is your signal which is enhanced by a factor of that, and this is called selective population inversion. If you have a whole lot of a big molecule and if you are transferring the population of one selected proton to one selected carbon, it is called SYNAPT, selective enhancement, insensitive nuclei enhancement by polarization transfer. You can do that. An amazingly powerful technique which I use this to the limit. I've used this techniques to literally hundreds of times. You have a big molecule and you want to transfer the population of only one proton to carbon 13. So you do everything here on a selective population. Only that proton which you are tuning up, and transfer the population of that selected proton to the carbon, and you see the intensity enhancement of only that carbon. Only that carbon. It's called selective insensitive nuclei enhancement by polarization transfer, or SYNAPT. SYNEPT. SYNAPT. What is the advantage? Amazing advantage. Which proton is coupled to which carbon? Right? Without knowing that which proton was coupled to the which carbon, I just select one proton and do the same thing on all of it, and at the end of the day I get an NF experiment in which only one carbon is increased intensity. Then that is my coupling partner, because population can only be transferred through a direct coupling, right? But if you want to transfer all the protons population to all the carbon in the system, is called INEPT, insensitive nuclei enhancement by polarization transfer. This is a very powerful technique, but if you want to use it selectively, lots of people, including Douglas Kinghorn, who actually done wonderful work on using SYNAPT, because at that time HMQC was not available. There was no technique available at that time to link proton with the carbon. The proton-carbon coupling was not there. So what he used to do was very simple. He used to have proton NMR spectrum in front of it and a carbon 13 NMR spectrum in front of it. And then he is now ITER actually, because I've seen him. He become from him to it, because, anyway. So selectively one proton, you do everything with the one proton frequency, and the population of that one proton is transferred to that one carbon which is coupled to it. And as a result, you see the signal enhancement of that only one carbon. So you discover the coupling partner proton and carbon, right? And if you are doing across the board that you have a full band of proton, a chemical shift, and doing everything for the full band of carbon, with full band of proton, and you're creating a situation in which a part of this is now transferred to this, then it is a non-selective enhancement of insensitive nuclei by polarization transfer, right? It is a technique which was extremely powerful, very, very powerful, and has been used to the maximum limit. Okay? Take the telephone call, please. See, this media is so fast that my brother was saying that something happened to the university. There is a problem in university, the clash of two groups of students. I'm really sorry about that, but I think we should really finish it as soon as possible and let you go. But anyway, for me it's extremely important for you to, for us to appreciate the following: selective population inversion. Selective population inversion in a coupled system. Remember, uncoupled proton carbon cannot be used as a polarization transfer medium, right? This is a coupled system in which you have a CH, and H is coupled with carbon and carbon is coupled with H, and both of them would appear as a doublet, for getting the natural abundance with the ratio of 1:4, right? But what you do the following: you carry out a 190 Vipers, and this 90 Vipers is at this situation. When you have a situation like this, then you give a 90 Vipers, and this 90 Vipers inverted into the longitudinal part. This transfer magnetization become longitudinal magnetization. One on the Z side and other on the negative sides. This is the site which is shared with it. They are shared together, These are the two situations which are shared together because both of them are on Z. And since both of them are on Z, they are ready to accept the population, and the population is accepted as a whole. This whole thing combined with this, add to this and add to plus Z. So you create a situation in which you have added the population into the population of polarization into the polarization of the carbon from the proton. And this particular situation is then giving a 90 Vipers. You brought it to the XY plane and then you detect it. If you want to detect at this stage, this would appear as a doublet. And if you want to detect at this stage, it would appear as a singlet. And if you want to make sure that all your protons, CH3, CH2s and CHs are on different phases, you do exactly the same as you have done, add a apt after that. An experiment of apt is added to this situation after this. Because everything, CH3, CH2s and CHs are right at this point. And now you add an apt test and you make them some negative appearing and some as positive appearing. And this would give you a tremendous capacity of not only enhancing the signal but also the editing the spectrum. Full spectrum experiment. I promise that I would repeat it 1,000,000 times if you don't understand. I will check your endurance and my own. Yeah. Yes, Omar. Carbon-13 is coherent because it is all on the negative Z. It is all on the negative Z, symbolizing the Boltzmann distribution axis. The proton is non-coherent, divided into two parts. The whole Boltzmann distribution axis of proton is now on plus and negative. And when you transfer this, a part is added into the non-existing part where there was nothing. So this Boltzmann distribution axis of the proton is added to the Boltzmann distribution axis of the carbon. situation in which you have a plus and minus, right, carbon. And in order to direct, you need to have a y pulse in order to bring it to the xy plane, because you cannot see it unless it become an xy plane. Any question regarding it from the other locations, please? How many of you think that you understand it now? Only one? Two? You have a question?
The application of the principle H pulse and the C pulse. Presumably it's done not simultaneously. You have to put it in line. So how do you follow
No, you can have a simultaneous pulse given to carbon and proton. For instance, this one is absolutely simultaneous. One is a spin echo pulse, the other one is a spin inversion pulse. So they are given exactly at the same site. This is also at the same time. This adds a magnetization vector, polarization to the carbon, and right at that time you give a 90 volts Y pulse to bring it to the XY plane. So the consequences of different pulses are different. Consequences of different pulses are different. And they influence each other also. For instance, I'll kindly remember that this pulse is influencing the carbon polarization. Right? And this pulse is influencing the proton orientation, divergence and convergence of signals. Every explanation about spin, about the selective population inversion is difficult than what we have presented in our book. And I invite you to kindly read this book. It's a beautiful book. You don't need to buy it. It is already there in our library. It is available in almost all libraries of the world. It's called Problem Solving by NMR Spectroscopy. And it's published by Elsevier. And this has the best definition on selective population inversion, polarization transfer, the easiest one. And the reason was that we were trying to understand it in the easiest way, and therefore we presented everything in a very easier way also. Okay? That Urdu version is also available on net too, and it is available in other languages too also. Okay. वो मकनातीसी गुमक मसाइल के हल के लिए कुछ इस तरह करके जिंदगी के मसाइल. Yes. So it's a beautiful language if you understand that, right? Okay. And this was done by one of my students actually. Any question from anywhere? Can we get an animation of this? Can you try this? Walaikum Assalam.
Sir, if aid to the signal of NMR signal, C13 signal.
This is called polarization
transfer.
transfer.
In the signal of proton?
Yes. You see, instead of plus 4,4, you see a minus 4. The doublet is now, the 4,4 doublet, 4 into 4 doublet is now appearing into plus 4 and minus 4. So there is a gross reduction in proton signal, but still visible, you know. And you don't want to see proton. Please kindly understand that you are not really worried about the proton. It is reduced subtly. It reduced to nil. Actually, plus 4 and minus 4 means 0, right? But you still see it. So you're not interested in proton, you're interested in seeing the population, so-called signal intensity in carbon-13. There is a reduction in the signal of proton which you don't record actually. You don't record it. And you see,
Excuse me, sir.
because of the selective population inversion and increase in the intensity of carbon-13. Yes, please.
Sir, any particular instrument be used for this magic of pulses?
Every NMR is equipped with inept pulse sequence. Now there are much better pulse sequences are available called DEPT, distortionless enhancement by polarization transfer. Theory is same. You don't have a distorted inverted peak. It's called DEPT, distortionless enhancement by polarization transfer. Well, one thing I want to mention here that now the pulse sequences in NMR spectroscopy are the composite pulse sequences. Like in music, the symphony is now added. Symphony is added. For instance, broadband, so-called spin echo, is, people don't say anything. They say gap spin echo, right? Inept, apt. Inept, apt, because you want to edit it. So this has mentioned apt, because they know that APT would make them appear in a two different orientation, right? Polarization transfer is not every technique. So if you're recording inadequate, which is incredible natural abundance double quantum transfer experiment, you add inept, inadequate. So you use this polarization transfer not only for recording proton NMR, carbon NMR, but you use this to enhance the intensity of everything. For instance, I want to tell you, don't want to confuse you, but I want to give you the example of inverse NMR spectroscopy. HMQC, HMBC, you probably have heard about it. This is a proton detected carbon spectroscopy in which there is an inverse polarization transfer. Polarization transfer sensitive to insensitive, like proton to carbon. Normal polarization transfer you have seen in a case in which you transfer the polarization from more sensitive nuclei to less sensitive nuclei. Inverse polarization is in which you transfer the polarization from insensitive to sensitive. You suffer with the sensitivity problem. People said this should be extremely easy, Why don't you do inept before that? Don't record it, Enhance the intensity of carbon signal and then use it to transfer it to the proton. You see, these pulse sequences become integral part of various experiments in which people are putting them together and creating an absolutely wonderful. Now we all understand that transfer of carbon to proton means that the intensity of the proton signal will be fourfold decrease. We all understand, right? As we see that from proton to the carbon there will be a fourfold increase, right? This fourfold decrease is an inverse technique, and you do it for a different purpose, which we will discuss this. But if we just add before it in inept, in which you have a regular polarization transfer, and then you take enhanced signals of carbon and transfer it to the proton again. Wonderful cheez hai. So you sometimes do it 6, 7, 8 times, Polarization transfer, inadequate is now polarization transfer from carbon to proton, proton to carbon, and then carbon to proton again, and then you see a proton detected inadequate experiments. So what I'm trying to say that what we have learned today is not a discrete experiment, although it really serves a historical purpose, in which people have used SIGNET, selective coupling between proton and carbon, in which people have used it for sensitive enhancement, but now people use polarization transfer as a general technique to improve the sensitivity of carbon and then use as a component of a larger experiment. Add it to somewhere, as you add the APT anywhere, So people are now doing lots of combination of different types. so many of it. And I'm pretty confident that by the end of end of this course, we will start appreciating the fact that it is a very interesting field, inshallah. Yeah, you can do that. I tried to do that also. I showed you see, the arrows which I showed you are the quantum transfer, forbidden and allowed quantum transfer. But it's not so easy to understand until you give them a number, 4 or 1 or 2. Quantum explanation of polarization transfer is not that easy. It's not that easy. And I would tell you when we will explain the NOE, I will tell you how allowed quantum transfer, single quantum transfer, double quantum transfer, forbidden quantum transfer. आपकी जो ख्वाहिश है ना quantum transfer, I will. Any question from anywhere before I leave? Thank you very much. I'll see you inshallah on Monday. Thank you. Assalamu alaikum.
प्रॉब्लम सॉल्व ये वाली किताब है पहली वाली दूसरी वाली किताब ब्लू कलर की आगे मुझे पता करें क्या हुआ
चलो दो ग्रुपों में लड़ा था ये के यूनिटी वालों को सकते हैं तो वो ये बोल रहे लड़ाई हो रही है यूनिवर्सिटी क्लैश नहीं हो रहा है